Welcome everybody in a new video. In this video I'll explain you how to calculate the total resistance in a circuit. So we'll talk about the resistor configuration in series and the resistor configuration in parallel. Okay, before I begin this video I would like to tell you that if you like my videos you could consider the idea to subscribe to my channel or give me a like or both, why not? Also in this channel I make videos in Italian and Spanish too, so if you're searching for English only videos, you just have to look in the playlist and there you'll find all the English videos. Well, let's go back here. Resistors in series and parallel. As we have seen in the last video, usually in a circuit we have a generator, a voltage generator, then we have a wire obviously, and a resistor, okay? But we could have more than one resistor. Why just one? We could have 2, 3, 4, 5, 6 resistors, okay? And these resistors could be configured in series and in parallel. Let's see what does it means. Let's make some examples to understand better. Let's imagine a circuit. We have this circuit, this is the voltage generator, plus and minus, okay, positive and negative side. And then let's say we have 1, 2, and 3 different resistors, and that's our circuit. Okay. Now let's imagine the voltage generator got like this is the generator is 10 volt. Okay, this is the tension of this generator, 10 volt here. Okay, yes, usually the generator is written like this with a. Okay, we have these 3 resistors, R1, R2 and R3. Now let's say that R1 is 100 ohm, R2 is 200 ohm, and R3 is 400 ohm. Let's say these are the values of the resistors. Okay, so how do I calculate the total resistance in this circuit? If I want to calculate the current, how should I do? Okay, it is very simple actually. When resistors are configured in this way, this configuration is series configuration. Okay, so these resistors are in series. This is a series of resistors. Okay, and if I had to calculate the total resistance in these circuits, I just have to do this. When they are in series configuration, I just do this. Total resistance is equal to R1 plus R2 plus R3. This is how I calculate the total resistance in this circuit. Okay, so I just do this is equal to 100 plus 200 plus 500 plus 200 plus 400. Okay, I haven't written the ohm symbol here, but okay, it's still fine. And I don't need a calculator for this. 700. Okay, the total resistance of this circuit is 700 ohm. And how do I calculate current? How can I calculate current? Well, I just have to do this. Generator, okay, divided for the total resistance of this circuit. And in this way, I'll find the current. To write it better, total voltage divided for total resistance. In this way, I'll find current. Okay, I just have to do this. So the total voltage here is 10 volt. And the total resistance is 700 ohm. So I just have to do 10 volt divided for 700 ohm. And in this way I'll find the current. The total current is 10 divided 700. Okay, 0.014 ampere. This is the current of our circuit. This current, the current flows in this way. Okay, so we have found the current of our circuit. Now, let's imagine these resistors are configured in another way. Let's imagine this is another circuit. Let's imagine now I have a generator as always, and then I have a resistor, and then I have another resistor. Just put in this way. Okay, I have R1 and R2. These two resistors, and this is my generator. Generator is always 10 volt. Okay, generator is always 10 volt. R1 is 100 and R2 is 200 ohm. Okay, so this is what I got here, and what should I do now? How could I calculate the total resistance? Well, this configuration where resistors are in this configuration, this configuration is the parallel configuration. Okay, so what does it mean? Well, now it is not the same like when they were in series, because when they were in series, I just had one current. You see it? It's just one current, okay? But now I will have a total current here. We'll call it the symbol of current and a T, which means total, okay? Total current, okay? And this total current will divide itself in two smaller parts, this one and this one. So we'll have current 1 and current 2. And then these two smaller parts will unite again here, and here we'll have again the total current. Okay, so this is what will happen in these circuits. And what about the total resistance? Well, I cannot do R1 plus R2 in this case, because it will not be correct. My result will not be correct. When they are in parallel, there is another way to calculate the total resistance. And how could I do? In this way. In this case, our total resistance will be R1 multiplied for R2, all this divided to R1 plus R2. Okay, so their multiplication divided, okay, their addition. Okay, so this is what should I do to calculate the total resistance when they are in parallel configuration. I just have to do this calculus. So it will be 100 multiplied 200 divided to 100 plus 200. And so it will be 20,000 divided for 300. So it will be, result will be 66 ohm. Okay, this is the value of the total resistance. Okay, you can see that when I put them in parallel configuration, usually their result is lower, okay, than their values. Okay, so this is how you calculate the total resistance when they are in series and when they are in parallel configuration. But about the parallel configuration, there is something I should tell you. Well, this formula, this way to calculate the total resistance, You can only use it when you have two resistance, 1 and 2, okay? But when you have more than two resistors in parallel, you have to apply another formula. You have to calculate in another way. Also, I will tell you another important thing about the parallel, but later. Let's see this other way to calculate now. So what will happen if I imagine I have a circuit and I have three resistors in parallel? So what will happen now? R1, R2 and R3. Let's imagine their values are this one, okay, these ones, the same values, okay. But I have three resistors. When I have more than two resistors, I cannot calculate the total resistance in this way. We are talking about parallel configuration. In parallel configurations, when I have more than two resistors, I cannot calculate the total resistance in this way. I have to apply another formula, another way. What is it? This one, the total resistance here, is calculated in this other way. I have to do 1 divided 4, 1 divided R1 plus 1 divided R2 plus 1 divided R3. Okay, I have to do this. It is a bit more complicated. Usually this one is a bit more complicated even to remember. This one is more simple because you just have to multiply and then divide to their addition. But this one is more simple. But when I have more than two resistors, I have to apply this. They could be even 4, 5, 6, 7. It doesn't matter. When they are more than two, I apply this. Okay, this one. If they were, let's imagine 4, I would have done this, always the same, but here that would have been plus 1 divided R4, okay, and so on. This formula, I can apply this even when they are 2. Even when they are 2, this one is always good. I just do this, just this, and it's still good, okay. But when they are more than 2, I am forced to apply this, okay. Now let's calculate the total R. In this case, it will be 1 divided 100 plus 1, 200 plus 1 divided 400. It will be this. This will be the calculus. It should be. And it will be, okay, 1 divided 0.01 plus 0.005, okay, yes, good, okay, and then here will be 400, 0. Point, okay, 0, 2, 5, okay. So we just have to addictionate this, and now we'll have then we do this last division and we'll obtain 75. Well, the total resistance here in this case is 75, and you calculate it in this way. Let me tell you just another thing about the way to calculate the total resistance when they are in parallel. If you have two equal resistance in parallel configuration, R1 and R2, imagine they are equal, completely equal, like R1 is 100 and R2 is 200. Well, if they are completely equal, their total resistance, you don't have to do any calculus. The total resistance will be their half, okay? Just divide one of them into half, and this is the total resistance. The total resistance here is just 50. Is just the perfect half of one of them, if they are equal, okay? Now let me tell you another important thing about the parallel. But maybe it's better if I tell you this at the end of this video, or maybe now. No, maybe later, okay. Now, what about a circuit with resistors both in parallel and in series configuration? Okay, let's imagine a circuit where I have this configuration. This is the generator. And then I have one resistors, two resistors, three resistors, and four resistors. R1, R2, R3, and R4. Okay, this is our generator. Okay, what will happen in this circuit? What will happen? Well, we have a current here, a total current here, which arrives till this point, and there here, in this point, will divide into two smaller parts, and then will unite again, and here we have again our total current, okay? But how do I calculate the total resistance for this circuit? Well, it is very simple. I just have to do this. Just follow what I do. Okay, let's imagine the resistors are R1 is 10 ohm, R2 is 20 ohm, R3 is 30 ohm, and R4 is 40 ohm. Okay, so these are the values of our resistors in this circuit. How do I calculate the total resistance? Well, in this way, let's begin with the parallel. Okay, I could begin even here, but let's begin here. Okay, we calculate the parallel between this and this one. Okay, and the parallel is, we'll call it RP, parallel resistors. Okay, we'll call it in this way, and it will be R3 parallel R4. We calculate the parallel in the way you already know. It could be this, okay, or it could be this way. Okay, we calculate the parallel. We don't have to make the calculus now, you already know how these things are done. So we'll calculate the parallel and we'll have a value. This value will be parallel R, okay. And now I'll redraw my circuit in this way. This is the generator. This is R1, R2, and now in place of these two resistors configured in parallel, I'll put their equivalent, okay, their parallel equivalent. I already calculated. Now here we have our RP. We calculated it in this way. It is just the parallel between R3 and R4. You can use this symbol to symbolize the parallel, okay? We calculated the parallel between these two resistors, and the parallel is called RP. So in place of these two, we'll put RP, which is the parallel. This is R1 and R2. It is perfectly equal to remove to remove R4 and R3 and put another resistor which is equivalent to their parallel, which is an equal value to their parallel, okay? So now how do I calculate the total resistance? Well, now I just have 1, 2, 3 resistors in series configuration, so I just have to do the total resistors is equal to R1 plus R2 plus Rp. Okay, and I'll have my total resistance in this way. If I want to calculate the current, I just have to do this voltage divided to the total R. Okay, let me tell you another important thing about the parallel configuration. So imagine I have this circuit now. I have my generator, resistor 1, resistor 2, resistor 3, and resistor 4. But here we have a parallel. Yes, here we got a parallel, but as you can see, its configuration is different from what I was used till now. I have two resistors on this side and one resistor on this other side. So what should I do now? It is a bit different, but still simple. Okay, and this is connected to the other thing I wanted to say before about the parallel configuration. When I see a circuit like this in a parallel configuration, resistors in a parallel configuration, it's not the resistors who are in parallels. Remember this. It's not the resistor who is in parallel with another resistors. The resistors are not in parallel. So who is in parallel? Sounds like the meme. Okay. What is in parallel? This circuit begins with a single branch here, and this branch divides into other branches. So it's not the resistors who is in parallel with the other resistors, it's the branch, this branch who is in parallel with this other branch. Remember this. It's not the resistor who is in parallel with the other resistor, it's the branch who could be in parallel with another branch. This branch, in this case, this branch is in parallel with this other branch, okay? So the branches are in parallel, not the resistors. Why do I say this? You'll understand it soon. In this case, I have two resistors on this branch. This is a branch. And here, I have another resistor on another branch. I say branch, imagine like the branches of a tree. These circuits begin with a single branch and then divides here into two branches and then they unite again, okay? But here we have two branches. And these two branches, this branch and this other branch, they are in parallel, okay? If one branch has one resistor and the other branch has one resistor, I just use this formula and I could say that these two resistors are in parallel. I could say this, but it's not really like this. It's still one branch in parallel with the other branch. Okay. How do I recognize when two or more branches are in parallel? Well, I just have to look at this. When they divide from a single point, they divide, it was one branch, one single branch, and they divide themselves from a single point. And then they unite again in another single point, okay, this. When they do this, when two or more branches do this, they divide themselves from an equal single point, from a common single point. When two or more branches divide themselves from a common single point and then they unite again in another common single point, when they do this, they are in parallel, okay? So in this case, we have two branches in parallel. And what should I do now to calculate the total resistance here? It's very easy. The first thing I do here is make the series between R2 and R3. So I calculate R2 plus R3. We'll call it RS, which is resistance in series, okay. And now I'll draw again these circuits, putting a RS in place of these two resistors, okay. I'll draw the circuit in this way. So there is R1, RS, and R4, okay. And now I can calculate the parallel between this branch and this other branch, okay. So Rp parallel resistor will be, I'll calculate this parallel, and Rp will be Rs multiplied R4 divided Rs plus R4. Okay, I'll do this calculus here, and I'll calculate Rp, parallel resistors. Okay, now I'll have R1 here and Rp. This is the generator. Okay, I have R1 and Rp. I have like a single branch now, and I can calculate the total resistance making just a series, just using the series calculus. Okay, so our total resistance now is just R1 plus Rp. Okay, and I'll have my total resistance now. Okay, so now you know a bit more about how to calculate the total resistance in different circuits. I hope this video has been useful for you. If you have any question, you could ask me in the comment. I'll do everything possible to answer you. Yes, for this video I think it's enough. So let's see you in another video. Okay.